Good day, everyone. Welcome back to another great session of this lovely tutorial class. Today we are going to be looking at a very important topic in the suite of subject is mathematics, and the branch of mathematics we're looking at today is calculus. And we are looking at the subtopic is differentiation of functions. How to check or how to differentiate functions and how they mathematics. Now, basically this class is going to take a general overview of all the aspects, most of the aspects we have in differentiation. So we are just going to be to the whole differentiation as a whole. We are not going to be looking at a particular topic here. We're looking at almost all the topics in differentiation in this class. So please, what you have to do for me now is to ensure you watch the video from the beginning to the end, because before I'm going to any function, I'm going to take a look at the function we are going to now. So please ensure you watch this video from the beginning to the end. It is very, very important you do that. Watch this video from what? The beginning to the end. And at the end of the day, if you have any question after watching the video, you can watch it over and over again. If the question persists, you are free to drop the question in our comment section. Thank you and thank you. Now, let's look at what we have today. What will happen is differentiation. Now, what is the meaning of differentiation? Differentiation is the art of finding the derivative of a function. How do we find the derivative of a function? That is the course for this class. How to find the derivative of what? Of a function. Now, basically, we are going to be looking at 5 basic functions. And from these functions, we are going to combine them to form other functions. The basic function we are going to be looking at in this class, and in this class, we are going to be moving around these 5 basic functions. The first function is, don't call it polynomial function. Polynomial function, so the first way, we'll have y to be equal to ax raised to power n, or x raised to power n. How do you differentiate things of this nature? If y is equal to ax raised to power n, we have done this, and this is just a revision class, just like a revision class. So we said the dy over the x means the relative related to this x. Now, what is the meaning of the polynomial function? It means we have a variable carrying a constant power. If the power is a variable, automatically it will switch to what we call exponential function. But when the power is a constant, but the base is a variable, we call it a polynomial. So, for the differentiate this polynomial, use the power to multiply the coefficient, and plus n times a, use this power to multiply this coefficient, then you remove 1 from the power, x, n minus 1. E.g., let's say we have y is equals to 3x squared. What is the y over the x? That will be 2 times 3 multiply the power with the coefficients and remove 1 from the power. Then x, 2 minus 1, that's going to give us 2, that's 2 times 3, that's 6. That's 6x raised to power 1, and it will give us 6x. When it raised to power 1 means that number, unless we want to call it prime. Let's call it prime. Then, another rule is that if you apply this rule now, if y is equals to ax, keep it. If y is equal to ax, dy over dx will also be a. The x will disappear. If y is equal to x, dy over dx will be equal to 1. If y is equal to a, dy over dx will be equal to 0. So take note of this, and this. We have ax, is equal to a. Differentiate x, related to x will be 1. So if you differentiate something with respect to that same thing, it will be equal to 1. You take note of that, it's very, very, very important. And if you differentiate a with respect to x, in the sense that there is no x in what you are differentiating, that will give us 0. So that will be called a constant. If is not present in that term. If this denominator is not present in the term, it means it's a constant. So if I differentiate anything that don't have x related to x, it becomes 0. If I differentiate it related to b, if that does not have b, it also becomes 0. Take note of that. So let's look at some questions. Let's have y to be equal to 3x. What is the y over the x? That becomes what? Ax becomes what? A. So 3x, the x will go since the power is just 1. So that gives us 3. Take note of that too. So let's say we have a combination of y to be equal to s4 plus s cubed plus x plus 10. What will be dy? What will be dy over dx for this? So the dy over dx for this will be what? This is part of the kind coefficient. Now the coefficient here is 1. But we are not going to put this 1. This one is also 1, this is also 1. This coefficient is 1, when you put it there. So this is going to give us 4 times x, 4 minus 1, plus 3 times x, 3 minus 1, plus differentiating x, respect to x, that's how what? That's like plus what? 1. This place is always there. Let's go to that place. So that will give us 0. It will give us 0. Remember? We're saying something that don't have x, respect to x, that will have 0. So at the end of the day, we will have 4x cubed plus 3x squared is 1. That's what we have. Now let's see that what we want to the summation of arrows start from 0 to infinity of any combination arrow times x raised to the power arrow. What will be dy over dx? Now I've already done something like that. Remember I told you for polynomial function the base will be the variable while the power will be a constant number. So you check where is x in this function? Now is x the base or the power? X is actually the base. So it's a polynomial. So the power is r. So for polynomial function, we use power to multiply the coefficient, we remove 1 from the power. So this one is the form of a f to this power n. This one is a, this one is acting as a. This one is acting as a. This one is acting as n. So what we are going to do? We are going to use this n to multiply this and remove 1 from the n. So we have n times a, we have arrow times this, going like this. Then you put the x back, then n minus 1, arrow minus 1. That's all. Or if we decide to put this arrow inside this place, we have from 0, arrow down from 0 to infinity of arrow times arrow combination times n combination arrow, x power n times minus 1. So this and this are the same thing. You guys multiply. So it's either you put the arrow, or you can put the arrow here. It's still good. I will put this arrow here. I will put it here. It's still good. You guys want to do. Put this arrow, multiply the coefficients. We move on to the arrow. Everything here has coefficient. Then just summation sign, multiplication sign, they are constant. To give you a constant number as answer. So that's how you do that. Now let's look at trig functions. Trig functions. For trig functions, this is for polynomials. This is how you differentiate polynomials. For trig, if y is equal to sin x, if y is equal to cos x, if y is equal to tan x, what is the y over dx? The y over dx for this will be cos x. The y over dx for this will be minus sin x. The y over dx for this will be sec squares. Sec squares. Sec squares. You did know that? Alright, we have cos s, cosec s, sec s. What will be dy over dx? What will be dy over dx? Now, we go and look at that. For sec s, when I go s and x. Please take note of that. So look at them. They are very, very important. Although we look at them, when we are looking at functions today, during trig group. Now, for exponential functions, I'm just quickly showing you guys the different functions we have in this class. I'm looking at them. I'm going to solve questions with these respective functions. Look at chain rule, function of the function, product rule, quotient rule, parametric differentiation, logarithmic differentiation, implicit differentiation, inverse shift functions, inverse parabolic function, gradient of the straight line, we may look at the equation of the straight line. We look at maximum and minimum value of the functions. Look at radius of curvatures and curvatures. Please ensure you stay with us. So let's look at exponential. Let's say y is equal to exponential x. The y over the x is equal to what? Exponential x. Those are what is equal to a raised power x. What is the y over the x of this? This a raised power x log a to the base e. This case now, x will not be the power. S will be the power, not the coefficient. If s is the power, automatically it will be called exponential function. And look at log functions. Question, how to look at how to differentiate log functions. For the reason, if y is equals to, let's say, log x to the e. Or, let's say y is equals to, in x. This and this are the same. In x, let it as log x to the e. So that you write it this way, x, write it as log x to the e. Alright, let's assume now we have still for the new function. Y is equals to log x, but to a base that is a constant number, not to base e. Base is not a constant number. Let's not say that in x, so the one over the x on this, you differentiate this, you have differentiate this compared to this x, you have 1 over x log a to this e, or 1 over x in a, because log a to b is equal as what? In. You get rid of that. Now let's look at hyperbolic functions. Hyperbolic functions. Let's look at hyperbolic functions. Let's say we have y is equals to sin x, y is equals to cos x, and y is equal to tan x, and so on. So we see our tranche. So if you differentiate this, we will have cos x. Differentiate this, we will have sin x. There's no minus for this. But for trig function, differentiate cos, we will have minus sin x. But for hyperbolic, the difference between this one and trig is that for hyperbolic, this one end is h. If you differentiate cos, we will have sin x, not minus sin x. We will say we have y is equal to tan x. We will say this one, and we will have sec square x. And that's we will have sec square x. That is very, very important. Now, these are the standard derivatives we have. These are what? Standard derivatives we have. Now we are going to be using, we are going to start using this standard derivative to obtain answers to problems. Now, standard differentiation techniques. Standard differentiation techniques. The first techniques I'm going to be looking at is called chain rule. Called chain rule. Chain rule. That is the first one. Chain product function and so on. But we are going to start from chain rule. Chain what? Chain rule. Now, the first chain rule we are going to look at is case 1. When you have y is equal to a function of x raised to a constant power. That is the first chain rule we are going to be looking at now. You have what equal to what? A function of x raised to a power of what? A constant number. How do you differentiate this? Now remember, this class is only about shortcuts. It's all about shortcuts. It's all about shortcuts. I repeat, this class is about shortcuts. So there's no need of solving much things. The y over the x must be the power times the differential coefficient of the bracket. What result? The differential coefficient of the bracket multiplied by the question itself, then you move on from the power. Use the power to multiply when you differentiate inside this bracket. Repeat this question again and you move on to the power. That becomes the answer. Number 1. Y is equals to 4x plus 1 is power 3. What is the y over the x? It will be the power times what? When you differentiate the bracket. Differentiate 4x, 4. Differentiate 1, 0, because there is no x in this. So this one will be differentiate on that, you have 4. You get 4x plus 1 will give you 4. So that is 4. So you repeat the question again and you move on from the power. So the same thing, this one gives us 12. 4x plus 1 is now 2. Answer. y is equal to 3x squared plus 2x minus 11. 3x squared plus 2x minus 11. What will be the y? This power, let's say this power 6. What will be the y over dx? This will be 6 to the power times, when you measure the bracket, measure 3x squared, you are going to have what? 6x. Measure 2, you are going to have what? Measure 2x, you are going to have 2. Measure 11, you are going to have 0. So use 6 to multiply when you measure inside this bracket, you have this. Then after that, you repeat the question again. 3x squared plus 2x minus 11, this power, you move on from the power. So everything, at the end of the day, we are going to be having our answer to be 6 bracket 6x plus 2 bracket 3x squared plus 2x plus 11 raised to power 5. Then we can say that is the answer. But if you wish to factor out the common terms, you need to use 6 to open this bracket, you are free. You have to also factor out common terms. So it's come between this 6 and this 2. So remove this one from the 6. So remove it from here, factor out from here, factor out from here, 2 from the 6. So 6 times 2 that comes 12. 6 divided by 2 times 3 is 3 divided by 2 times 1. Then 3x squared plus 2x minus 11 plus 2x minus 11 raised power 1000. Y to be equal to let's do 5x plus 3 raised to power 10. 5x plus 3 raised to power 10. What will be by this for this? We can do that. Let's say try class 1. What will be by this for this one? We can do that. Answer will cross out. Try to do it. What will be the answer? The answer is going to be 50 bracket 5x plus 3 raised to power 9. And sure you get an answer. Remember what you do? You say this is give us 10. Give us 5. 5 times 10, 50. If you give us a grade, you will not become around this. So let's look at something very nice. Another question that is y is equal to, let's go have cos 6x. Cos equals 6x. What is the y over this? What is the y over this? How do you solve this using this rule? Because cos x is equal to x. So this, to obtain this mystery now, to unravel that mystery, we are going to write this in the proper form or in the proper way. We will close this cos x in the bracket. So this is equivalent to cos x. Everything is past 6. Equivalent to that. So if you want to do this now, we're going to have 6 multiplying differentiating cos x, we're going to have minus sin x. Minus sin x, that's what we're going to have. So we use 6 to multiply with differentiation in bracket, we have minus sin x. Then repeat the question again. Cos x, then we move on to the power. So that is going to give us minus 6 sin x. Then cos x, this is our what? 5. So finally, for that, the y over dx will be equal to 6 sin x cos x raised to power 5. So we are going to say cos 5x. That equals the answer. So please, remember the minus here. Don't feel to put that minus. Very important. Minus 6 sin x cos 5 cos raised to power 5x. That's what we do now. Now we're going to look at another case. Another important case of this same form. Another important case of this same form. You see what we're going to have. Now let's look at that. Alright. Let's look at more questions. Under differentiation. Now let's have a differentiation of this form. Let's say if y is equals to the square root of the function of x, what will be the y over the x? Now if it is square root, we take note of this. If it is square root of any function, the y over the x will be equal to the f prime of that function divided by 2 times the question of the y over the x. E.g., let's say y is equals to the square root of 3x plus 1. Square root of 3x plus 1. The y over dx It's going to be what? The f prime. What's the meaning of f prime? F prime means differentiate what you have inside that bracket. That is the f prime of the function. The prime of the function means differentiate the function. So if I differentiate 3x now, I'm going to have 3. Differentiate 1, I'm going to have 0 over 2 times the same question, which is 2 times 3x plus 1. So we're going to have 3 over 2 roots 3x plus 1. That becomes the answer. Let's say we have y is equals to the root of cos x. Let's say we have y is equals to the square root of cos x. What will be 1 over the x? What will be y prime now? Y prime means the 1 over the x. Means differentiate with respect to the variable in the function. So differentiate right now, I'll tell you what's y prime. That's another way to write it. So I'm going to have differentiate inside the root, we're going to have minus sin x. Then divided by 2 times the question, which is cos x. Now let's say y is equals to the square root of tan x. Then what is the 1 over this? What is 1 over this? 1 over this is what? Differentiate inside this, differentiate tan x about sec square x all over 2 root tan x, which is the question. That's how we do this part. So let's look at more. Let's say y is equals to the square root of x cubed plus 3x squared minus 5x plus 13. What will be the y over the x of this? The 1 over the x will be differentiate inside the root. Differentiate inside, we will have 3. Let's go back to differentiate, we will have 3 times x, that's 3x. 3 minus 1, we will have 2. Plus 2 times 3, we will have 6x. Minus differentiate this one, we will have 5. Differentiate 13, because there's no x there, is 0. Over 2 times the question, which is x cubed plus 3x squared minus 5 minus 5x plus 13 plus 13. This is what I could have. So if you remove this 0 now, that becomes a final answer. So I would like you to look at this. If y is equals to the square root of 4x plus 1, what will be y over dx? The y over dx will be, if you change inside this space, you have 4 over 2 times the initial question. That's all. 2 here 1, 2 here 2. So this will give us 2 over the square root of 4x plus 1. That's what I'm going to have. So this is how we run through this package. So let's look at something like this. Chain of this nature. If y is equals to, let's say, exponential function of x. If y is equals to exponential function of x, the 1 over the x must be, the f prime of that function times the former question. That becomes the 1 over the x. You will differentiate, what you have to do, you differentiate the power and use the answer to multiply the question. Use the answer to multiply the question. So look at it. Let's say we have y is equals to exponential sin x. Look at this. What you do here, the 1 over dx, what you do? You differentiate this power. We have cos x. Then use the answer to multiply the question. Exponential sin x. Answer. Look at something. If y is equals to exponential 1 plus x squared, dy over dx will be what? Answer will become, try to see if you can do it too. Answer becomes 2x exponential 1 plus x squared. If y is equals to x over 1 minus x squared, dy over dx will be, okay, let's start this one. Differentiate 1, differentiate this one, 0. Minus, differentiate x, 2x. Use this answer to multiply this. 1 minus x squared. So this will give us 0 minus 2x as minus 2x exponential 1 minus what? X squared. That's all. So let's go one more. If y is equals to exponential tan x, if y is equals to exponential tan x, dy over dx will be what? What will be over this? Differentiate tan x, differentiate the power, we will have sec square x. You to multiply the question, exponential tan x. Answer. So that's how we roll here. So I'm going to look at more questions now. More questions. So let me look at this. Let's say if y is equals to exponential 8x, what will be over the x? Differentiate 8x, we will have 8. You need to multiply the question. 8x. Answer. If y is equals to exponential, let's say x squared, exponential x squared, dy over dx will be what? Differentiate x squared, we have 2x exponential what? X squared. See, it's a very simple thing. So this is how we'll be solving questions in this class. Shortcut. This class is for shortcuts only. for shortcuts only. So ensure you watch the class from the beginning to the end. We still have a lot of questions to poke our nose into. So just let's have more questions. Now, remember the one we looked at was if y is equals to exponential, let's say 12x plus 1. We say dy over dx will be what? We differentiate the power, we have what? 12. This will multiply what? The question, this is what 12x plus 1. This will become the answer. Now, let's look at something, look at another thing, another exponential function. Now, any function that has a power as a variable is an exponent, because as you are changing the value of the variable, it will be affecting the power. So it will become an exponential function. So if I happen like this, if y is equals to a raised power x, as long as the power is x, it's an exponential function. So if I want to do this now, check all exponential function. The question must be inside the answer. That's one thing. The question itself must appear in the answer. That's one thing about exponential function. The question must come outside. So in this, the answer doesn't, the question must come out. So if I have to do like this, you differentiate it, the answer is going to be the question first, then you take the log, because this one is different from this. This base is a constant number, but this base is e. So for this one now, you just change the question, use the question now to multiply log of this base to base e. That's all. Because if you take the log of this e to base e, the thing becomes 1. That's why we don't take log of all these other ones. But there's no need of doing that. So what are we now going to do? Look at what we are going to do. Very important thing. Let's look at questions now. Let's say we have y is equals to 3 raised power x. What is dy over dx? That becomes what? 3 raised power x log, what is the base? 3 to base e. Answer. More questions. If y is equal to 4 raised power x, what do you want over dx? 4 raised power x log what? 4 to base e. Answer. If y is equals to 11 raised power x, dy over dx will be what? 11 raised power x log 11 to base e. Answer. If y is equals to 10 raised power x, dy over dx will be what? 10 raised power x log what? 10 to base e. And look at another thing. Remember, log to base e is same as in. So we can also say the 1 over dx for this one now is a raised power s in a. Don't write it like that. A raised power s in a, because in and natural log are the same thing. So what you do, let's say we have to like this one. If y is equal to 5 raised power s, you can also write the answer as the log over ds is equal to 5 raised power s in 5. Answer. That's what I'm trying to say. Let's say we have y is equals to let's say 15 raised power s plus 3x plus 9 raised power x. Now this one is not 3 raised power x, so this one is 3x plus 11. What is dy over dx? This becomes, differentiate this. Remember, exponential function as far as a variable. So if you want to do this, we're going to have 15 raised power s in, let me use it, in 15 plus differentiate 3s, 3 polynomial. Differentiate 3s, that's how it's not, there's no between 3 raised power x and 3s. Let me add to this. Let me add to this. Plus 3 raised power s plus 11. Let's add that to it. So if you want to differentiate 3x, it will be 3 because that's a polynomial function. But look at this. Look at it. If you want to differentiate 9 raised power x, not 9s, 9 raised power x, it's not going to be 9 raised power x in 9. So differentiate all those other powers x. So I'm going to differentiate 3 raised power x in 3. I'm going to 3 raised power x in what? Or 3 raised power x log 3 to base e. Then differentiate 11. Differentiate 11 what I do have? I'll give us 0. Differentiate 11, we're going to have what? 0. So I'll give this one s in 15. In 15. And 15 raised power s in 15. Plus 3 divided 3 s 3. Plus 9 raised power s in 9. Plus 3 raised power s in 3. Differentiate 11 because there's no s there to give you 0. That's why I go back. So let's do something like this. Let's say y is equals to a raised power a function of x now. A raised power a function of x. How are we going to look at this? If y is equal to a raised power a function of x. If y is equal to a raised power a function of x, so let's look at this now to see what we are going to have. A raised power a function of x. A raised power a function of x. If I differentiate both of them, differentiate the one by this will be, look at it, a raised power a function of x first times the f prime of that function. Remember, prime means differentiate a function. That's the meaning. Then either log of the function to base e, or you use in of the function to be, there's no base in in, there's an in of the function, that is all. So you want to write down that is dy over dx will be a raised power the function times f prime of that function in of a, that is of e of the base. You don't take the function again, you will be log of the base only. So let's have y is power 3 raised power 2x. What is dy over dx? dy over dx will be 3 raised power 2x, the question first, remember, times differentiate 2x and bring back 2. You take the log of what? The base to be the answer. That's all. Okay, let's something very important. Look at this. Look at this. If y is equal to, let's say, 5 raised power 10x, what is dy over dx? This is what? 5 raised power what? 10x times differentiate 10x, go back 10 log of what? The base. What's the base? 5 to be the answer. If y is equal to 10 raised power 10x, what is dy over dx? That was what? 10 raised power 10x times what? Differentiate 10x, and we will have 10, then in of what? What is the base? The base is 10. Answer. That is in or use log to be is e. Now let's start something. If y is equal to 5 raised power sin x, what is dy over dx? That will be what? 5 raised power sin x. Remember the question first, times differentiate sin x, and we will have what? Cos x log of the base to be the answer. So that's how we roll here. I told you everything we are going to be doing in this place must be shortcut. It's a class for shortcuts. This is shortcut movements. That's what we call it. The moment of shortcuts. That's what we are writing. Moment of shortcuts. A place to learn shortcuts in calculus. So let's try something. Let's say y is equals to, let's have more question. 2 raised power s squared. If I go to 2 raised power s squared, what is dy over dx? Which one gives us what? 2 raised power s squared. And that is s in the numerator. So the special function. Then times differentiate s squared. We will have 2s log of what? What is the base? 2 to be the answer. So we're going to look at more questions now using shortcut. More questions. I will solve more questions on this aspect with shortcuts. Right, more questions. Let's say if y is equals to, let's say we have 4 raised power 4x plus 6 raised power x. What will be dy over dx? Remember this what? For this 4 raised power 4x times differentiate 4x, we will have 4. Then in of what? Of the base. Then plus, what about for this? 6 raised power x. If you say even differentiate x 1, that will not cause any problem. A of the base, answer. That's the answer. If I have y to be equal to 4 raised to power what? That's 11 s squared plus 1. What will be dy over dx? dy over dx will be 4 raised by 11 s squared plus 11 then times what? Log of what? Okay, wait. And before you do multiply, remember we measure the power. We measure 11 s squared. We're going to have times 2 times 11, 22x. Measure 2 and 0 and give us in on the base, which is answer. Now let's say we have, let's just look at one more here. We ask this. If y is equals to, so if y is equals to, let's say 6 raised power s cubed. Y prime is dy over dx will be 6 raised power s cubed times measure s cubed 3s squared. Then in of what? 6. Or log of 6 to base e. Now let's start. If what about now like this? Y is equals to a function of x raised by another function of x. F of x raised by g of x. How are we going to do this? If remember all the questions that we solved since, the denominator is a constant number. There's no s in the denominator. Check. Everything we do is under this exponential function. Everything is just denominator is just constant. What about we now have a question like this? Let's say we have something like this. Numerator is x, denominator is just the power and the base. Something by the power and the base, not numerator and denominator. Because we have numerator and denominator for fractions only. Now, whenever we have a question, the base is a function of x, the power is also a function of x. How are we going to do that? So everything we have been doing since, all the base are just constant numbers. All the base are just what? Constant numbers. So how are we going to do the one that have x in the base and x in the power? So this one will be a little bit more complex, but it's not still hard. The one over the x, we follow this model. The one over the x must be the question of x times when you differentiate the power, and take the natural log of the base. Take the natural log of the base plus when you differentiate the base, and divide it by that same base. Differentiate the base and divide it by that same base. Then use everything to multiply the power. That will be the dy over dx. That's what we have as dy over dx. So please take note of that. It's very, very important. So the answer is going to be write the question of x, then differentiate the power, take the natural log of the base, add it to this one of the addition. This is the model we are going to be following. Add it to when you differentiate this base over the same base, then use to multiply the power. Look at what I'm going to do. Look at what I'm trying to say. The answer is going to be, look at the answer. When you write the question of x, then differentiate this power, you have 1. Differentiate x, you have 1. Then times you take the log of this base, to base q, plus differentiate this base and divide it by the same base. Differentiate x, you have 1. Differentiate this x, you have 1 over that same x. Then times the power is what? X. Answer. So if you find this one, I'm going to have x square x. 1 times log x to be z plus this, you cancel this, you have 1. That is this is the answer to this. Let's have something nice. Y is equals to, x square s squared. X square s squared. How are we going to do this? Remember the first thing is the y over the x will be. First you do, write the question out. X square s squared. Then differentiate the power. Differentiate s squared. What do you have? Anything else you have 2x. Anything else you have 2x. And take the log of the base. Use it to multiply. Differentiating the base over the base. Differentiate x. We're going to have 1. Divided by this same x. Then use everything to multiply. The power is what? S squared. That will be the final answer. So this one of these x will cancel this. And we are going to be having remember we have s here. Also have s here. You can bring it out. We have s, this one s squared. Then you bring one of these x out. Then we have 2 left here and log x. You can have this s plus only 1 will be left here. Answer. Then we have y to be equal to s squared power 2x. What is the y over the x now? So we are going to follow the procedure gently now, so that we all be able to follow. So just try to follow. This one is very lovely. Write the answer. Don't write the question out. Then use to multiply. Differentiate the power first. You have 2x. Then take the log. If you differentiate this power, what are you going to have? Not 2x. Then you take the log of the base. The log of what's the base? X to base e. Then you add it to when you differentiate this base. Differentiate x. You have 1 over this same base x. Then use to multiply the power is 2x. Answer. First thing, write the question out. Differentiate the power, you have this. Take the log of the base. Then differentiate this base. Divide it by the same base. Then you should multiply the power. Just power, base, power. Power, base, power. The power, log base, the base, then power. That's all. So differentiate the power, take the log of the base, then differentiate the base, divide it by the same base, and multiply with the power. That's all. So we're going to have something like this. S power 2x. Then we have 2 log. This we can even cancel this. 2 and 2. They are common. I can bring it out. But we have 2 here, we have 2 here. Come on. I bring the 2 out. We have log x to be z here. Plus 1. Answer. So we have the last one we're going to do here will be, let's say we have s power sin x. Or s power cos x. And the case will be, now we have s power sin x or have s power cos x. So what's going to be the dy over dx for that? First, you write the answer out. Then you got s power sin x. Then the next thing you are going to do, what is the next thing you are going to do? Differentiate the power, you have cos x. Then you take the log of the base. to the log of the base plus differentiate the base over the base. Differentiate the base, we have 1 over what? X, and use to multiply the power to sine x. Sorry about that, you cannot see that. Sorry about that. This one is sine x. So let me write it again. You have the power, then differentiate the power, we have cos x. Use the question, differentiate this one, we have this. You take the log of the base, then let me use him instead of using this. Let me use him on the base, then plus differentiate this base. Look at the base here. We have 1 over the base. Use to multiply the power. Use sine x. That's all. So it will give us x to the power sine x, then cos x in x plus 1 times sine x can give us sine x over x. That's what we're going to have. So we're going to look at more questions now under topics like, let's look at logarithmic, trig, in case of trig, functions, logarithmic functions, and the rest. Let's look at more questions now. More questions. Let's look at more questions now. Let's say we have this case, y is equals to log e of the function of x, or this one can also be y is equals to e of the function of x. Look at something like this. We have e of the function of x. How do you differentiate it? The differentiation will be the f prime of that function over that same function. Answer. F prime of the function divided by that same function. That becomes the answer. So let's look at something like this. Look at something now. Look at what we're going to look at now. Something very nice. Look at it. Something very sharp. Very nice. Y is equals to, let's go to log sine x to base e. What is the y over the x? The y over the x will be differentiating sine x. What do you have? You have cos x over the same sine x. Answer. Cos over sine. What is cos over sine? In trig ratios, cos over sine is cos. Cos x over sine x is cos x. This is inverse of tan x. So think about sine over cos x, sine x over cos x is tan x, and cos x over sine x is cos x. You take note of that too. Take note of that. Then let's say we have y is equals to log e of x squared plus 3x plus 5. What will be the y over the x? Differentiate x, don't differentiate the front, divided by that same front. That is it. Differentiate x squared, what do you have? You have 2x, differentiate 3x, you have 3, differentiate 5, you have 0 over x squared plus 3x plus 5. That will give us 2x plus 3 over x squared plus 2x plus 5. Whatever, I can have something like this. Let's have something like this. Let's have something like this. Look at this. Log e of 2 to the power x plus 2x plus 1. How will you do this? How will you do something like this? The y over the x will be, remember 2 to the power x, we that we're going to have 2 to the power x in 3. Let me use log 2 to be c. We use 2x, we have 2. This polynomial is exponential. The negative 1 has 0 over 2 to the power x plus 2x plus 1. That gives us 2 to the power x log 2 to base e plus 2 over 2 to the power x plus 2x plus 1. Answer. That is the answer. Just differentiate the front divided by that same front. So let's say we have this case. Okay, let me just do one more. If y is equals to log 6x plus 4. Let me say 6x plus 5. And then to be c. Class, what becomes the log of this? Translate yourself to 6 over 6x plus 5. That will become the answer. Try and do that yourself. It's very, very important. Then, let's say we have this case. If y is equals to log of a function, this one is just log, this one is not in. Log of a function of x to base a, not in. This one is different from in, if it's having the base of e. If base is e, that's why it's in. This base is a, any other number is not on this. So differentiation now we are going to have the f prime of that function all over the function times log of the base to base e, or e. Look at it. F, it can also be f prime of that function, and then divided by the function e of the base. Look at this. You differentiate this function, divide by this same function, and use the answer to multiply the denominator to multiply e of this base or log e of this base. Okay, let me do an example. Let's say y is equals to log x to base 10. What will be the word value this? The word value should be differentiate x, you have 1 over x, then times e of 10. That is what. Just use this denominator, which is the same question, to multiply e of this base or log of this base to base e. That's what I'm trying to say. So let's look at something like this. Look at more things. Y is equals to log of base 5 to base 5, or let's say 7x minus 13. What will be the y over the s? That will be differentiating 7x minus differentiating 7x of 7 minus differentiating 13. Since there's no 0 here, s here is 0 over 7x minus 13. The e of what? Not e again. Yeah, that one will be e because having a base of what? E. Anyone that have base of e is e of 5. That's it. So let's say we have y is equals to log of exponential x, log of exponential x to base 3. What's the word by this? This will become what? This will become what? Differentiate exponential x is going to be exponential x over that same exponential x in 3. This will cancel this. That will be 1 over in 3. Answer. This is mathematics. This is mathematics. So you go and try this one. Try this one yourself. If y is equals to log of 6x to base 4. To base 4, yes. The answer is going to be the word by this should be 1 over in 4. 1 over x in 4. 1 over x in 4. Or 1 over x log 4 to base e. So it will be the answer. So we try it to see what you are going to get. So we're going to look at more questions from, let's look at trig functions. Look at trig functions, hyperbolic functions now. Trig functions, hyperbolic functions. Alright. Now trig functions. Now if y is equals to, let's say, sine 6x, what will be the y over this? Now for trig functions, if you want to differentiate, you start from the end part. Start from this end. So you start differentiating from the end. Now what is the end function of 6x? Differentiating 6x, you have 6. Differentiating this sine, you have cos. You don't repeat the front part, which is 6x. Answer. Look at what I mean. If y is equals to tan sine 7x, tan sine 7x is 3 because the first function is 3. If everything is 3, it's 3. The first function there determines the function we are talking about. But the last function is where we start from if the function is a trig function. So you start from, what is the last function here? Y prime. What will be the last function? 7x. Differentiating 7x, you have 7. Then after this, you go to the next one. Differentiating sine, you have cos. Then you repeat this one back before you move. You must repeat front before you start moving. Then after you repeat this one, you repeat this one, you go back to this. Differentiating tan, you have sec squared. Then what is the front side of what is the front of sec squared? Sine 7x. Answer. Let's go back. Okay, let me look at another one. Let's see y. Let's see y is equals to cos x. Cos x. Can you see that? What will be y prime? Just what is the last function here? We have cos x is this is the last one. The one that is carrying s here is the last one. If both everything is carrying s, it's not a chain rule. We use another method to differentiate the question. So if you try to write and start from this point, if it's chain, that means you cannot separate. If all these one cannot stand the rule, it's chain using chain rule. This chain rule, start with this last one. Very quick process, we're going to have minus sine x. That's what we're going to have. Now differentiate this cos. You see our minus sine. Minus times minus become plus. Okay, let me just put it. But you don't put, you put the minus in the front side. Okay, let me put this minus here. Okay. We're going to have minus cos. Okay, we are saying this cos, and we're going to have minus sine x. Then differentiate this cos. Is equal to have minus the cos sine minus sine. You're going to have minus sine there, then you repeat the front back, which is cos x. After the differentiate this one, you're going to have minus sine. That's what you're going to have. You're going to have minus sine. Or let's do it this way so that you get it better. Differentiating cos x, you have minus sine x. Then differentiating this cos, you have minus sine as well. Then you repeat this from that, which is cos x, cos x. Then differentiating this one, you see have minus sine. Then what's the front of this cos x? Cos x. Answer. So look at what I'm doing now. Most of you don't know how to use this one. That's how I was trying to move the minus, the front side. You're going to have minus, minus, minus. Minus times minus, plus. Plus times minus, minus. I'm going to minus sine x, sine cos x, sine cos x. Answer. Let's do it another way. 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 Look at this. Differentiating cos x. Y prime. Differentiating cos x, you're going to have minus sine x. Differentiate this cos, you're going to have minus sine. What is the difference of this cos? Cos s. Not really cos s back. Then differentiate this last cos, you're going to have minus sine for the last one. Differentiate this one, you're going to have minus sine. But what is the difference of this last one? Cos s. Cos x. But look at it. Minus times minus plus some minus will be left out. You see minus sine s, sine cos s, sine cos s. That's all. So look at it. Let's have y is equals to have tan 3x. Tan 3x. Then the y over there should be. Remember this is hyperbolic now. Anyone that have h in this place is hyperbolic. The other one should be. First of all, you see the same way. Differentiate this front side, we're going to have 3. Differentiate this tangent, we're going to have sec squared 3x. Answer. If y is equals to, let's say we have sine 6x plus 11. What will be y prime? Differentiate 6x plus 11, we're going to have 6. Differentiate sine, we're going to have cos 6x plus 11. If y is equals to, cos x squared. What will be y over the x? If the y over the x is not far from differentiate x squared, we will have 2x. Differentiate cos, not cos, so cos, we will have sine, not cos, not minus sine. We will have sine, and you repeat this x squared back. Answer. If y is equals to, now let's look at how to differentiate functions now. For example, now let's say we have something like this now. Something like this now. Let's say we have cos x times s squared. Or then let's write it like this. S squared cos x. Let's look at how to differentiate something like this. If y is equal to this, s squared cos x. How you do that? Now, if you saw that we have two functions here and they are functioning, we now use what product rule. Now, we are not into product rule. Now, if you want to do the product rule, the dividend over dx will be, therefore, we have 1, we have 2. The first thing, you will differentiate this first one. Differentiate this first one, you have 2x, then you leave this one, cos x, then you add d2, go back again, then differentiate this, and leave this one, you have s squared, differentiate cos x, sine s. So at the end of the day, we have s here, we have s here. You can just move the s out. We have 2 cos x, then we have 2s here, s and s, like s and s. S times x, like we have s, why we are having s squared. So one of the s will go, only one will not be left out. Sine s will be here. Answer. Look at it. We also have like this. Y is equal to x cos x. Look like this. See, this product function. We go to this product here now. What do we differentiate on our y prime will be? First, differentiate this first one. Differentiate x, we have 1. Then leave the second one, cos x. Then plus differentiate the second one and leave the first one. Differentiate the second one, we have minus. Then leave the first one, sine x. So the energy we are going to have cos x minus x plus minus x sin x. Let's go have y is equals to sin x cos x. Y prime will be differentiate this first one. No, differentiate the first one. Differentiate this first one. Differentiate cos. So we have cos x. Then you leave the second one, which is still cos x. Then plus leave this one now. Differentiate the second one. We're going to have minus sin x. The minus will come be at the front of the answer. And it should be at the front. Not front here. This place. This one is separated in 2 terms. The front of the 10. So we're going to have cos s, and cos square x, minus x plus x minus, sin x, and cos sin square x. Answer. Let me look at more. Let's see, we have y is equals to, let's see, x squared exponential 3x. What is the y prime? Y prime will be, differentiate this first one. We have 2x, then leave the second one, plus, differentiate the second one, and leave the first one. We have x squared, then differentiate the second one, 3x exponential 3x. So you now check, what is common between them? We have exponential x, we have exponential, we have x, we have 2x here. Remove one of those x and leave the other one. So y prime will be, x will go out, exponential also exponential 3x is common. Then if you move this x and exponential 3x and only 2 will be left here, then 1x will still be here, 3 will still be here. You have 3x answer. This is how you do for product rule. Now we're going to look at more questions. Let's go to quotient rule now. We'll go to implicit function and so on to see what we are going to have. Let's see we have y is equals to x plus 1 times x plus 3. What will be the y over ds or y prime? Differentiate this first one. Differentiate x plus 1. Differentiate x, you have 1. Differentiate 1, you have 0. S1. Then give the second one. Then plus. Differentiate the second one, give the first one. You have x plus 1 is there. Differentiate this one. Differentiate x, you have 1. Differentiate 3, you have 0. Also be 1. So 1 multiplied here, you have x plus 3. 1 multiplied here, you have what? X plus 1. You have s plus what? Plus 1. So this one gives us s plus s has 2x plus x plus 3 and s plus s, you have 2x. 3 plus 1, you have 4. Then let's say we have y is equals to, x squared log x to this e. What is the y over ds? Let me use the y over ds now. What is the y over ds? Differentiate this first one, you have 2s, and leave the second one. Plus, differentiate the second one, leave the first one now. We're going to have 1 over x. So we cancel one of these. S here. So move the s out, move this s out, move this one out. Then 2 log s will be left here. What will be here? Only 1. So that's what we're going to have as your answer. So what about, we now have something like this. Y is equals to x over sine x. Not s and s now. S over, they are now over, something like this over this. What are you going to have? You have s over sine x. What are you going to have? S over sine x. What are you going to have? Now this one now, this is a quotient function. When we get that, we are going to use quotient rule. Now look at how do you use quotient rule? Look at it. The y prime will be differentiate this first one. You have 1. Then you give the second one. See the same thing. But this one you have put minus, not plus. You put minus. Then minus. Differentiate the second one. Leave the first one. You have x cos x. Then you now divide the answer by the denominator. Then you square it. That is the only difference between these. You still differentiate the top, leave the downside. Differentiate the downside, leave the top. Then the only thing that you now divide this answer by what you have this denominator and you square it. Just like c over this denominator, the same thing. For everything, you will now square it. You're going to have 1 times x give us sin x minus x cos x all over sin square x. You can say sin divided by this, that give us 1 over sin x minus s. Sin cos over give us cos over sin s. You will not see very simplified. So I can just leave the answer. Decide to leave the answer that way. So y is equals to this will have sin x over x squared. The one by this will be differentiate this first one. You have cos x then you leave the second one. Minus, remember the second one, you have 2s, then you leave the first one, over the second one, the downside, the square. Answer. It's a very simple thing, though. Very 100% simple. Do you know what I'm talking about? 100% simple. Very, very simple. Very, very, very simple. So, what I'm going to do now, at the end of the day, the y prime which is divided by the s will be, we have s, okay, cos s times s squared, that will be s squared cos s. Not cos s cubed, but this s cannot multiply this, not possible. Because this s and this cos s are together. Which here are together. Take note. Minus 2x sin x over s power 2 times 2, that is 4. So s here is s common, we're going to have s out, we have s cos x plus 2, okay, minus 2 sin x, but s is coming out, s, you have to move one of this s and this one out, then over s4. So this one cancel 1 out of this one will be reduced to 3. So this one will be here. That will become the final answer. That becomes the final answer. Or you can also say one of these s out, you have 3 left, one is out here, one is out here, one left. You can only do that if they are common between all the terms. If s is not common between all the terms, you cannot cancel s will be here, will be here, will be here. If it's here and here, it's not here, it will not work. Take note of that. It's very, very important. Now, what about now like this? Let's have like this. Let's have y squared plus s squared plus 3x plus 1 is equal to 0. And I say, what is the y over ds? What is the y over ds? The y over ds will be equal to minus, when you differentiate x, divided by when you differentiate y. Look at it. Minus ds means differentiate only the s out. The y means differentiate only the y out. Look at it. Minus, if I'm differentiating x, anything that don't have x with it at all will be 0. Anyone that have s with it, I will differentiate the s out and leave the other ones there. That's how it is done. Look at it. This one don't have s at all, 0. This one have s, differentiate s, you have 2x. Differentiate 3x, you have 3. Differentiate 1, 0. That's what I'm trying to say. For y now, differentiate the y squared, you have 2y. Just as I'm differentiating this, differentiate as if you have differentiated x. So differentiate this s squared, there's no y there, 0. Just as you did, you just like inverse that case. Anyone that don't have y, 0. Then differentiate this one, we're going to have 0 there. Differentiate this one, we have 0 because there's no y, there's no y, there's no y. So at the end of the day, we'll be having something like a minus 2x plus 3 all over 2y. Don't say 2 cancel 2 because there's no 2 here. So these 2 cannot cancel these 2 because there's no 2 in this other place. So this becomes the final answer. So let's say we have y cubed plus s cubed plus 4sy plus 3 is equals to 4. Okay, let us say plus 4 is equals to 0. Which one all becomes divided by this now? First thing, minus will come out. Override minus, because minus is the derivative. So what you do, differentiate only the s out first. Anyone that have a 0, differentiate this one 0. Differentiate this one 3s squared. Differentiate s out. Okay, differentiate 4s, you're going to have 4. Differentiate x, you're going to have 1. 1 times everything, you will still be 4. Why? Why would this? Why will not be 0? Why is y not 0? Because s is standing with x. It's not standing with somebody that can, something like that will stand if the heat that is coming. So you differentiate now, y will still be alive. Because s is standing with the y. That's how it is. So we differentiate only s and leave the rest. You have this. Differentiate 4, 0 over. Differentiate this one related to y. I have 3y squared. Differentiate x, there's no y here at all, 0. Differentiate, look at this, s is here. This s will not be 0 because there's y here standing with it. Differentiate y out. Differentiate y related to y to be 1. 1 times 4s will be what? 4x. Differentiate 4, 0. So I'm going to have minus 3x squared plus 4y over 3y squared plus 4x. Answer. Don't say 4 cancel 4 because 4 is not common between all the terms. Don't say 3 cancel 3 because 3 is not common between all the terms. It's only cancel out when they are common between all the terms. So this becomes the final answer. So these ones are called implicit functions. How do you differentiate? This one is implicit functions. So we are going to look at more questions now under these implicit functions. Let's do. Alright, look at more questions now. Let's go have s power 4 plus y power 4 plus 3s squared y plus y plus y squared is equal to 17. What is the value of this? So first thing, before you can use this shortcut, everything must be equal to 0. So when you remove this and everything this other side, move it to this side and put it to 0. So we're going to have s power 4 plus y power 4 plus 3s squared y plus y squared minus 17 is equal to 0. Move on to this side equal to 0. Don't say no, it means a lot. It means with the sign will change, don't do that too. So what will be the y over this? The y should be minus differentiate s out. We will differentiate this one over 4s cubed plus differentiate y 0. Differentiate this s squared. We are going to have 2 times 3. Now 6x. Y, don't touch y, leave it like that. Then differentiate this y 0. Differentiate this y 0. Differentiate something 0. That's all. Then over. Differentiate this one for y 0. So I'm going to go. Differentiate this one for 4y cubed plus differentiate this y here. Differentiate this y. We're going to have 1. 1 times 3s squared. We have 3s squared plus differentiate y. We have 1 plus differentiate y squared. We go 2y. Answer. So differentiate s out first. The y side will be 0. The next thing, differentiate y out. You have the final answer. So let's say we have something like this. Lastly, okay, we still have more questions to solve. X plus y plus cos sy cos sy. Should I use cos now as a new sign? Then you cos as a new sign. I will use the 2. It's equals to 2. What will be the y over the x? What will be over the x? Remember, when we take cos 3x, what will become the answer? If y is equal to cos 3x, why can't we what? So for the differentiate cos 3x, differentiate to s, differentiate s out of the 3, then differentiate cos out minus sign. Because we fill this front back. Remember that. So if I say differentiate this one, I'm going to do minus, differentiate x, you have 1. Differentiate y 0. Differentiate cos sy. Everything here are together. So what you do? Take y as a constant number. Differentiate only the s out. You know how? Differentiate this form. Differentiate forms. Differentiate x y. Differentiate to s. Differentiate only s out. You know have 1. 1 times y. You have y. Differentiate cos. You know have minus sign. You repeat the front back sy. Remember you have to move everything to one side. So move to this side. Put it to 0. Differentiate 2. You have 0 over. Don't be confused. Differentiate this, you have 0. Differentiate y, to y, have 1. Then plus. Now, differentiate this front. Differentiate sy, differentiate to y now. Differentiate y, we have 1. 1 times x, we have s first. Then differentiate cos, we have minus sign. Then you repeat this from back. Remember that minus 0. Differentiate 2, and then 0. So at the end of the day, the y over the s becomes minus 1 minus y sin sy over 1 minus s cos sy. That's all. Let me do another one. If y plus x plus sin sy is equal to 4, what will be the y over the x? Remember, you move this one side to this side and you put it to 0. The y over the x, this one will be what? Measure this one minus, measure this one 0, measure this s 1 plus differentiating x y, measure to x, measure s out, so you have 1. 1 times y, you have y, you have y. If you differentiate x and y, differentiate this one to s, differentiate x, you have 1. This 1 times y will give us y. That becomes the answer. So we'll write the answer down. The next, differentiate cos, differentiate sine, you have cos, 1 minus cos. You repeat the front back, which is what? Sy. Differentiate 4, you have 0. You have differentiating this related to y, you have 1. Differentiating x related to y, 0. The differentiate sine sy related to y, differentiating y out of this place, leave s. Then differentiating sine, you have cos. And you repeat the front back, answer. Then look at another one, very important, very important. Now, let's look at gradients. Let's look at gradient. How do you calculate for gradient of the function? For example, I can say, what is the gradient of this function? What is the gradient of this function? What is the gradient of the function? X plus y plus log xy to base e is equal to 0. So what is the gradient of this function? What is the gradient of this function? Now, gradient of a function means when you differentiate the function once. If you differentiate the function once, you're going to have the gradient for that function. You have what? Gradient for that function, or the slope of that function. So look at, let's differentiate this one to what we're going to have. Look at it. Remember for logarithmic, remember for logarithmic, what you do for base e, what you do for y prime, you don't differentiate the log and divide it by that same log. Remember, differentiate the front, divide it by that same front. So that's what I'm going to do now. The 1 over the x becomes minus, differentiate x, you have 1. Differentiate y 0, that is 1. Differentiate log xy to base e related to x. Remember, differentiating xy related to x, don't differentiate x out. Only y will be there. Then divided by the same thing, is what? Xy. Then over, differentiate x for y now, x will be 0. Differentiate y, you have 1. Plus, remember, this part together, this question, this part together. So when you do, differentiate xy related to y now, differentiate y out, x will be there, answer. Then divided by this same log, which is what? Xy. If you cancel this, you cancel this. So we'll be having 1 plus 1 over x all over 1 plus 1 over y. So what I'm going to do now, you multiply this place by xy, also multiply this place by xy, so that everything will be linearized. This x cancel out this x, this y cancel out this y. So I'm going to have xy times 1, we have xy plus xy times 1 over x. This x will cancel the out this x. We are going to have y times 1. We will have y over xy times 1. We will have xy plus, then this one times this, y will cancel y, x times 1 we will have x. This will give us, if that x is common, y is common. So we do also like y bracket x plus 1 over x bracket y plus 1. Y is common, move the y out, that x is only one will be left, but there's nothing there. Then move x out, y will be here, only x will be here. So this will be the final answer to that. That will be the final answer to that. So also, that's also find the gradient of the function. Find the gradient of the function. Y is equal to cos x at x equal to 30 degrees. Find the gradient of this function now. Let's see what I'm going to have. Gradient is differentiate once. Differentiate. One by this of this will be what? Minus sine x. Minus sine x will be minus sine 30 degrees. Now what is sine 30 degrees? That's half. Answer. Sine 30 is what? Half. So that's how we do for gradients. Now let's look at parametric functions now. Parametric functions. Parametric function is, well, for example now, two functions linked up together with a parameter. Let's say we have y is equal to t squared and x will be equal to t cubed. This t now is linking x and y together. So if I say differentiate y with respect to this x, the answer is going to be the differentiation of y over differentiation of x. Y prime is differentiate y over x prime is differentiate x. Look at what I mean. Differentiate t squared, we have 2t over differentiate x squared, we have 3t squared. This will 3 cannot cancel, but this one can cancel one of these. So we have 2 over what? 3t. Answer. That's what I don't have. Answer. But also have to see differentiation in the sense that you say differentiate it again the second time. So you differentiate this one again the second time. Don't differentiate this again the second time. So let's do another one. We have another question. Let's say we have y to be equal to sine t. Let's say x equal to sine t and y is equal to cos 2t. What will be y over the x and what will be square y over the x squared? What will be over the x and what will be square y over the x squared? Now let's look at that question to see what we are going to have. After this, look at inverse trig. an inverse hyperbolic function. Let's see what we're going to have. Remember the question we're having? Y is equals to sine t and x is equal to cos 2t. What is the y over ds and the square over ds squared? I already said dy over ds is what? Differentiation of y over what? Derivation of x. Or derivation of y times 1 over derivation of x. That is y over ds. Now look at another thing. I'll give you the shortcut for the square over ds after this. So let's do this now. So we're going to have differentiate y. Differentiate y. Differentiate y. So we're going to have differentiate y. Let's see what we are going to have. Now look at one thing I'm going to correct. This is the x. X is sine t. Y is cos 2t. You think it like that? Yes, y is equals to t and s is the sine t. Yes, y is equals to t, y s is the sine t. You think it like that? Then differentiate y now. Differentiate cos 2t. Differentiate 2t. We're going to have 2. Differentiate cos, we're going to have minus sine. Repeat 2t back over. Differentiate sine t. We're going to have cos t. Answer. That's going to be good. That's going to be the answer. But from trig function, sine 2 theta is equal to 2 sine theta cos theta. For example, now look at the cos sine, not cos, sine 2. Let's say a. You see it as 2 sine a cos a. So sine 2t now will be 2 sine t cos t. Why are we using this? Because this cos t can cancel out this denominator too, which is cos t. So instead of going to use sine 2t, I will just use 2 sine t cos t. These are the same thing. These are the same. I'll just use one. I'll just use this 2 sine t cos t. Because this and sine t, 2t in trig ratio are the same thing. Then divided by cos t. This one will cancel this. And now having this times this, I'm going to have minus 4 sine t. I'm going to have minus 4 sine what? Sine t. Minus 4 sine what? Sine t. Minus 4 sine t. That's what we are going to have. Now, what about d square y over d square? Now, this will be equal to differentiation of the y over d times 1 over the derivation of x. This is how you get the square over d square. Differentiation of the y over d times 1 over the derivation of x, or you just say differentiation of the y over dx divided by the derivation of x. So I'll just say derivation of y over derivation of x, or derivation of y times 1 over derivation of x, or you just say differentiation of the y over dx over differentiation of x. Means differentiation of the y over dx again and divided by differentiation of x. That is square over dx square. Look at what I'm trying to say. Differentiate this y over dx. Differentiate minus 4 sine t. Don't differentiate only sine t and leave minus 4. We're going to have minus 4 cos t. Then differentiate x. Differentiate x, we're going to have cos t. Cos t cancel cos t. That's how we minus 4. Answer. This is what I'm going to have as your final answer. So this is how we rule when it comes to parametric function. Okay, let's look at this. If y is equals to 2u squared and s equals to u plus u cubed, what will be dy over ds? Dy over ds will be differentiation of y over derivation of what? X. What is the derivation of y? What will be the derivation of y? We do this. What is going to be differentiation of y? That will give us derivation y. We will have 4u. Derivation x. Derivation better to u, we will have 1. Differentiate u cubed. We will have 3u squared. Answer. That's it. Simple as A, B, C. Simple as what? A, B, C. Now, remember I do summary. I just do summary. Successive differentiation means when you differentiate a particular function 1, 2, 3, 4, 5, 6 times, and so on. And so on. E.g., if y is equal to sine x, find y prime plus y prime prime plus y prime 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 plus y prime prime, okay, y iv. This one means differentiate it once, differentiate it twice, thrice, and 4 times. What are you going to have? When I differentiate it once, differentiate this one, I'm going to have cos x. Differentiate it again, you're going to have minus sin x. Differentiate it again, you're going to have minus cos x. Differentiate the fourth time, you're going to have minus cos x minus sin x. That will be sin x. So add it together, that will be equal to y is y prime cos x plus y prime minus sin x plus y is y prime minus cos x plus y prime that is y4, that will give us sin x. So minus cos x minus cos x 0. Minus sin x plus sin x 0. Answer will become 0. That becomes the answer. So this is the law of just love in mathematics. Can you just solve a question, everyone will be filled up, at the end of the day, the answer will be 0. The answer will be 0. Given that y is equal to sine 2s, let me use cos 2s now. Given that y is equal to sine 2s, let me use sine 2s. Find the cube y. Find the cube y over the x cube at s equal to 0. Find the cube y over the x cube at s equal to 0. This means differentiate this. Look at it. The y over the x means differentiate once. The square y over the x square means this one we differentiate 2 times. Very again. The cube over the x cube 3 times. The 4 y over the x 4 times. 5 times. 6 times. Take note of that too. So if I differentiate one first time, I'm going to have differentiate sine 2s, I'm going to have 2 cos 2s. Remember that. Differentiate one again. I'm going to have 2 first. Differentiate cos 2x. Differentiate cos 2, I'm going to have minus 2 sine 2x. Will give me 2 times 6 x minus 4 sine 2s. Differentiate this one the third time now. I'm going to have minus 4 first. Differentiate this sine 2s. Differentiate sine 2x. I'm going to have what? 2 cos 2x. And minus 4 times 2. 2 times 2. That's minus 8 cos 2x. That is our the cube s over the s cube. So at s equal to 0, now let's say put 0 as minus 8 cos 2 times 0. That will be minus 8 cos 0. That will give us minus 8. What is cos 0? Cos 0 is 1. That's how will be minus 8. Answer. The answer to that one is not 0. Don't think all the answer will always be 0. It's not always that possible. So now let's look at more things now. Right. Now, let us look at the inverse trig functions. Now, let's look at inverse. No, we have looked at actually the trig functions. And now we're looking at the inverse trig function and inverse hyperbolic functions. So you are going to take note of this. These are the keys to this part of differentiation. The keys are as follows. Now, number 1. If you have y to be equal to the sine inverse of x, dy over dx, if you differentiate this, you're going to have 1 over the square root of 1 minus x squared. That's what you're going to have. You take note of that. Very, very important. Then, the second one is if you have y to be equal to the cos inverse of x, dy over the x is going to be 1 over, this one will be negative of this first one. 1 over x minus 1 over the square root of 1 minus x squared. Then if y is equals to the tan inverse of x, then dy over dx will be equal to 1 over 1 plus x squared or 1 over x squared plus 1, because addition is commutative. So that is 1 plus x squared or x squared plus 1. Both of them will be very, very, very correct. Now, let's look at real life problem or just examples. Let's look at examples to see what we are going to have now. Remember, if I go to the sine inverse of x, the over the x will be 1 over the square root of what? 1 minus x squared. If I go to the cos inverse of x, the over the x will be what? Minus 1 over square root of 1 minus x squared. This and this are the same, but this is just the negative of this sign. Then if I go to the tan inverse of x, the over the x is going to be what? 1 over 1 plus what? S squared. Now, I can explain this model in another form. Look at it. Can you see? You can have 1, 1, 1. And you have 1, 1, 1. Now this one in the denominator is constant. It must always be in the derivative of this inverse. But the one in the numerator is not constant. That the one must not always be there. Now, how do we change this one? Or how do we get this one? Now, this one is constant. But this other one was going to be from the derivative of anything that will be present in this place. For example, like differentiate x, you have 1. Differentiate x, you have 1. Differentiate x, you have 1. But this other one is constant. One is just like that in all the questions. For example, let's say we have something like this. Y is equals to sine inverse of 2x. Something like this. You see, what is the y over the x? Look at what I'm trying to explain. Now, if you differentiate this, you have this one. For you to get what is in this numerator, you must differentiate anything acting as the angle of the inverse tree. For example, if I want to get the numerator of this sine inverse, I'm going to differentiate 2x, I'll have 2. It will not be 1. That one can change. You got that from the derivative of that front side of the tree function. What about the denominator? For the denominator, this other one is always 1. That one is constant. Always constant. But what about this x? This x and this x are always the same. This and this are the same, but you now square it. So if you look at this one, look at this. We have 2x here. So it will be very wrong for you to put x there. What you are going to do now, you are going to put 2x here. You don't put 2x. The same thing here, they are playing here, but you are going to square it. Look at it. So square, so square, so square. So you are going to square it. That will be the answer. So this is how we roll through the inverse function. So you use that, we're going to have 2 over the square root of 1 minus what? What is 2 square? 4. We are going to have 2 square, s square. S square, answer. 2 square, s square, answer. Now, 7 more questions. If y is equals to the cos inverse of 6x, if y is equal to the cos inverse of 6x, dy over dx will be what? You measure 6x, we have 6 over. Now, remember, for cos inverse, we have minus. So this minus is still there. The minus is with the derivative, from the derivation. Minus from the derivation. So we are going to have minus. We measure 6, we are going to have 6, we are going to have 6. Then the square root of what? 1 minus the same thing. 6, and you square it. That's what you are going to have. So you are going to have. Look at it. Then this one is going to give us minus 6 over the square root of what? 1 minus what? What is 6 squared? 36 squared. Answer. More questions. If y is equal to the tan inverse of 4x plus 1, what will be the y over the x? What will be the y over the x? The y over the x will be for tan 1 over 1 plus x squared. And remember, I said you can get this upper one, derivative, the numerator. So if you want to get that upper side now, differentiate this. Differentiate 4x, you will have 4 plus differentiate 1, 0, because that side don't have x. Over, remember this one don't have square root, is not numerator from tan inverse. So you will have 1 plus the same thing here, which is what? 4x plus 1 and square it. So as you can see, this and this will change, but this one is always 1. Check. It's always 1. It's always 1 there. But the other ones will be changing irrespective of the question we are having. So this one is going to give us 4 over 4 plus what? 4x plus 1 squared. So you may decide to open this bracket. If you are free to open the bracket. You are free to what? To open the bracket. If you want to open the bracket now, you are free. You can just say, okay, let me open the bracket. I'm going to have 4 over 1 plus. Now, if I open this bracket using shortcuts, look at the shortcuts. If you want to say 4x squared, 4x squared now give us 16x squared. Then plus, not this plus, just say plus, this plus. I say plus 2 times 4x, that is 8x, plus 1, also be 8x. Then plus 1 squared is what? 1. Or you can just say 4x plus 1 times 4x plus 1. Also look at that. Open the bracket. Although this is the answer, if the answer is not like this, it will be in this other point. You said that this other side will be expanded. That you just expand it. So it will give us 1 plus 1. We will have 4 over 2 plus 8x plus 16x. So 2 here, 2, 2 here, 1, 2 here, 4, 2 here, 8. See, 2 can go into everything. So you have to write everything, all the terms by 2. I'm going to have something like 2 over 1 plus 4x plus 8x squared. Or you can also say 2 over 8x squared plus 4x plus 1. It's still correct. Also say 2 over 8x squared plus 4x plus 1. It's still very, very correct. But if you have minus, this one cannot be minus, this one is not minus. So going to the other side, you have minus there. So this is how you open this. Or you don't multiply this one times 2. 4x times 4x, that's 16x squared. 4x times 1, that's 4x. 1 times 4x, that's 4x. 1 times 1, that's 1. 4x plus 4x, that's 16x squared. Plus 8x plus 1, 8. I just want to get this stuff here. Or just say 4x squared plus 2 times 4 times 1 plus 1 squared. Now that plus is always plus. But the first plus must come with this sign. That's how to do it. That's what I'm trying to say. You have to like this. So you want to expand something like this. Let's say A plus B raised to power 2. Not 2. Or if it's not 2, it will not work. You just say A raised to power 2 plus 2 times A times B plus B raised to power 2. This will work. For if the power is 2, if the is a binomial to 2. So that's going to give us something like this. Then if it's A minus B raised to power 2, the 2 will be A raised to power 2. Then minus A times minus this 2 here times A times B times A times B. Then plus the last sign of the plus B squared. That's what it is. So this is how you expand. You have to use a shortcut. Just see, this one is like this. Plus 2 times this times this. Plus the last one will not be plus this squared. If it's minus, we say A raised to power 2 minus 2 times A times B plus this squared. That's what the last sign will be plus. But the first sign determines the sign with the two terms inside the bracket. So that's one question. If y is equals to the tan inverse of sine x, what is the y over the x? What will be y over the x? The y over the x will be differentiating sine x, we're going to have cos x over the square root of 1 minus what? Sine x squared. That's sine square x. That's what I'm going to have. I try this one. Try this one. If y is equal to the tan inverse. So remember, tan don't have square root. For tan is 1 plus. It's 1 plus s squared. So this one is going to be 1 plus sine s squared. That's sine square x. That's what I'm going to have. Okay. Then look at sine inverse of cos x. So the over the rest of this is going to be minus sine x over 1 plus cos square x. If y is equal to cos inverse of 2x cubed, dy over the rest will be what? 6x over square root of x is minus 1 plus minus what? 1 minus 4x6. So we are going to have. I try the following questions. So we are going to have this, give you this. You can try that. Try these questions. See what you are going to have. We are going to look at more questions now under this same inverse tree functions. We are going to have more questions. Alright, more questions. Let's see, we have y to be equal to sine inverse of x over r. Y is equal to the sine inverse of x over r. What will be the y over the x? Remember, the y over the x will be, first thing, differentiate this. Now, we are having x over r. That's what we are having. So, if you check the denominator, there is no x there. And we are differentiating no x. So, because of that, you are going to differentiate this function as a polynomial function. Since there is no x in the denominator, you may not need to use quotient rule. Although if you also use quotient rule, it will still work for you. But the short way to do it, if you discover that there is no x in the denominator of the function and you are differentiating with respect to x, and you have x in the numerator but no x in the denominator, what you just do, differentiate only the numerator and forget about the denominator. That's how to do it. Just differentiate only the numerator if there is no x in the denominator. Denominator means if there is no x in the downside, differentiate only the upper side and leave the downside alone. So we will have differentiating x, we will have 1 and leave the downside over the square root of 1 minus what is x over r squared. Quick same thing squared. So we will have something like 1 over, that's 1 over r first, all over the square root of 1 minus s squared over r squared. These two will affect both of them from indices. So we will have, now, we want to linearize this now. We want to linearize it so that everything will be very, very okay. So remember to have square roots. To our square root. So I'm going to differentiate. We are going to move this square root, arrow square away from this place. Look at what I'm doing now. To move this arrow square away, I'm going to multiply this term by arrow square. So that arrow square times this arrow will cancel arrow square. Look what I mean. I have 1 over arrow over the square root of 1 minus sx square over arrow square. I use arrow square to multiply this. So that this arrow square will cancel this. That will go. Now for the question not to be invalid now, the second will be valid. This other term I also multiply with arrow square. Okay, that was very good. So the denominator now is satisfactory. But the upper side will change if you don't also work on the upper side. So I'm going to use equivalent arrow square to multiply upper side. But if you check the upper side, there is no square root. You check the downside, there is square root. That is the problem we have here. The downside has square root. The upper side don't have square root. So if I use arrow square to multiply this over the upper side, now if you saw that if I move this arrow square out of this square root, you saw that the square will go away. For example, now if I want to multiply the numerator now, I will multiply by the square root of arrow square. Just like this. So I'm going to what I'm doing now, I'm using square root of arrow square to multiply both sides. Each square root enters square root. Square root can just come and take over from a solve. So before I multiply the numerator now, I'm going to take the square root of this arrow squares that I'm using. So what is the square root of? You see this other square root? I'm going to take the square root of arrow square. What is square root of arrow square? This one cancel this. It does be r. So I'm going to multiply the numerator with just r because the square root of arrow square is r. I'll now move it out. This will multiply the numerator. Since the numerator now have square root, that's how I'm going to do that. So this arrow will cancel this arrow. This one cancel this one. I'll be having 1 over the square root of arrow square times 1 is arrow square minus n square. So that's going to have as your answer. So you take note of that, it's very, very important. Now let me try another one. Let's see, if y is equals to the tan inverse of x over a. The tan inverse of x over a. What will be y over the x? Now for this, the y over the x is going to be differentiate this. Differentiate this, we're going to have what? Differentiate x half. See there's no in the denominator. Then goes 1 over a. Then divided by, remember for tan inverse, there is no what they call there's no square root. So we're going to have 1 plus s squared, which is x over a, then you square it. So it's going to give us 1 over a over 1 plus s squared over a squared. Now to remove this a squared from that denominator, what you do? You multiply this one by a squared, also multiply this one by a squared, then you don't multiply this one by the same word, a squared. Why? Because there is no square root in the denominator that will cancel the square away. But this one, there is a square root here. Cancel that square on top of this arrow. You normally do to multiply the numerator. But this one now, no square root to cancel anything. So just rule. So this one give us 1 of this a will cancel this a. 1 times a will be a over. Then a square times 1 is a square plus this one cancel this a square. Answer. So please take note of that. It's very, very important. If y is equals to, let's say sine inverse of 6x plus 1. What will be y over the x? Now this one is 6x plus 1 will have 6 over front of 1 minus 6x plus 1 square root. Remember sine inverse square root of that. So let's say I'm going to do now another question. Let's have another question. If y is equals to, let's say, sine inverse of x over 3. Sine inverse of x over 3. That's what this is what we're going to have. So the 1 over the x for this is going to be differentiate x over 3. We're going to have differentiate. There's no x in the numerator. Differentiate the numerator out. So we're going to have 1. Differentiating x, we're going to have 1. Leave the 3 over the square root of what? 1 minus x over 3 and you square it. So this one is going to give us 1 over 3 over the square root of 1 minus x squared over 3 squared. So remember how to do this now? How to do x over r? Can you remember that? What you leave us? We're going to multiply this by what? We multiply this one by 3 squared. Also multiply this one by 3 squared. So that this 3 squared will cancel this one. For the person want to check now, I will take the square root of 3 squared and use multiply. What is the square root of 3 squared? 3. I will now take the square root of 3 squared and use multiply the other side. So this will cancel this. We have it 1 over Square root of what is 3 times 1? 1 times 3 squared. That will be 3 squared. And what is 3 squared? What is 3 squared? 9 minus s squared. Answer. What I will have as your answer. Now, we are going to look at inverse hyperbolic functions. Inverse hyperbolic functions. Inverse of hyperbolic functions. This is for 3. Let's take note of this rule. This is the model. This is the code. This is the main D here. So let's look at that for hyperbolic function and the inverse of hyperbolic functions. Let's go. Now, inverse hyperbolic functions. We are going to look at now inverse hyperbolic functions. The first one is we have y to be equal to sine inverse of x. What will be the y over the x? The y over the x of this will be, remember sine inverse is what? 1 over the square root of 1 minus s squared. Over here now we are going to have 1 over the square root of 1 plus s squared or s squared plus 1. That's what we're going to have. So now you have 1 plus s squared, and you have s squared plus 1. Your plus is commutative. You can write any one at first, then you get the same answer. So if you have y to be equal to the second one is cos inverse of x, the y over ds will be d minus c. And guess that? No, there's no negative sign here. This is going to be 1 over the square root of s squared minus 1. It's just something the same thing with this. Where you know it's plus, so it's minus. But you cannot interchange this. It's not possible. It cannot be s squared minus. When it's 1 minus s squared, it's sine inverse. It's not even cos inverse. So it must be s squared minus, because minus is not commutative. Subtraction is not what? Commutative. So take note of that. So it must be s squared minus 1 square root. So I don't have. See, look at it. If you remove this square root now, you're going to have another answer, which is still part of inverse functions. That's why you should be very careful with these answers. If you remove this square root now, it will become tan inverse. You remove the square root. 1 over 1 plus. Alright, now let's look at for tan inverse. Tan inverse of x. If I do tan inverse of x, what will be the y over the x? That will be 1 over 1 minus s squared. Look at this. This is not commutative. It cannot be s squared minus 1. Put s squared minus 1, I've changed it to another thing. So all this one that has minus inside, you cannot interchange it. It's not possible. If you have plus inside, it can be interchanged. For example, now, you can write this other way. Take note of that, it's very, very important. You can write this as 1 over s squared plus 1. The same thing as 1 over 1 plus s squared. So plus is commutative, but minus is not. Just take note of that, it's very, very important. Now let's look at some examples. If y is equal to, let's say, cos inverse of 3x. What will be the y over the s for that? What will be the y over the s for this? Now, the y over the s is going to be, now for cos inverse, remember is 1 over, how do we get this 1? Differentiate this s, get this 1, this s will be this f here. So differentiate this 3x, we're going to have 3 over the square root of, what is acting as s there? 3x. You have to 3x, and you square it, then minus 1. So we are going to have 3 over, the square root of 3s squared, that would 9s squared minus 1. Answer. Remember 3 squared is 9, s squared is s squared minus 1. So we are going to have. And let's look at if y is equals to, there's a sine inverse of 6x plus 5. Let's do this. The y over the s will be, differentiate 6x, we're going to have 6. Differentiate 5, we're going to have 0. When you differentiate this, you have 1. Remember these ones inside the denominator, they are constant, but the numerator is when you differentiate the angle, you get it. That is the shortcut there. So the next thing, divided by the square root of, for sine, you have sine, you have s squared, you have square for sine, s squared plus 1 or 1 plus s squared. S squared, 6x plus 5. That's what is that s there. Answer. So if you remove this one now, we're going to have something like 6 here over 6x over 5 squared plus 1. So let's look at this. If y is equals to, let's say tan inverse of tan x. What will be the y over the x? Will be 1 over the x here. This will be, what is 1 over the x there? Remember, tan inverse is 1 over 1 minus s squared. So you differentiate this s to get this 1. So you differentiate tan x, you have sec square x over 1. There's no square root with this. 1 minus this one is constant. What is happening as s here? Tan x. And be tan x squared. If you square everything like this, you take it this way, it's the same as writing it this way. You put the square to the side for you write x. Don't put t to the s, that is different from tan, the s, everything is squared. So let's say we have y to be equal to, let's say we have tan inverse of sine x. What is the y over the x? This will be differentiate sine x will go cos x over 1 minus sine square x. That's what we will have as the answer. As simple as that. Now, is it not like amazing to you that look at calculus as you are just going, you don't just solve question, you just see answer. You don't solve question, you just see answer. This is how calculus is supposed to be. It's as lovely as this. Now look at it. We are going to do integration the same way. Just write answer, question, answer, question, answer. That's how we're going to be doing it. I'm going to teach you guys the shortcuts. That's what I'm doing. This is called shortcut approach. This one is feasting on shortcuts. That's what I'm doing. Feasting on shortcuts. Let's look at if y is equal to, let's say, sine inverse of expression x. What expression x? What do you want by this? You want by this? You want? Expression x over the square root of expression x squared plus 1 plus 1. Because it's x squared plus 1. We say this without this. The same as if you said the square plus 1. Continue the other one. So do this. Then you can do it. If y is equal to sine inverse of exponential 3x. What will be the y over the x? What are you going to have there? You are going to have okay. I said you do it on your own. So I'll give you 3 and then 3x all over the square root of 1 plus exponential 3x everything squared. Or 1 to be 1 plus exponential 6x. That's still very, very correct. So please ensure you do that. It's very, very, very important. Very, very, very important. Now, let's look at more questions. Let's say y to be equal to now. Let's say y to be equal to let's say cos inverse of sine x. Cos inverse of sine x, what is the y over this is going to be differentiating sine x over minus cos x over square root of, remember for cos inverse is x squared plus minus 1. X squared is that x sine x squared, that's x squared minus 1. Answer. What is what? That is y is equal to another one. And you want to if I solve one, you solve one now. If y is equals to let's say tan, let me use sine now. Sine inverse of 9x dy over dx will be 9 over square root of 1 plus 81 squared. Try this one to see if you can do it. If y is equals to cos inverse of let's say log x to base e dy over dx will be 1 over x over the square root of log x squared minus 1. Try to see if we can get this one first. So we can get this one. Now, the thing that will be 1 over x, the square root of log x to base e squared minus 1. Is it correct? Only one will be just of this, that has to come to the other side. It's still very, very correct. Try to see if we can do this. Try to see if we can do this. Now, let's ask the maximum and minimum value of the function. The maximum. We are looking at how to differentiate function things. Now let's check how to apply this differentiation we are doing in solving real life problem now. Application differentiation. Application of what? Differentiation. Now, if you have displacement and you have you are asked to look for velocity and acceleration, how do you look for them? Let's look at those stuffs now. Look at those stuffs. And remember, we did kinematics. I'm going to check that. We already have videos on that. Kinematics, the differential calculus from that kinematics. I'm going to look at that. Now it's already there. Now it's already solved. It's already solved. So we're going to look at maximum and minimum value, maximum and minimum points of the function. Then we're also going to look at the curvature and radius of curvature of a curve. Now let's go.